Part 2, Chapter 4, Work, Energy, Power, and Efficiency. At the end of this lesson, you should be able to understand the principle of conservation of energy. In your previous lesson, you learned about two types of energy, the kinetic energy and potential energy. So, energy can be converted from kinetic energy to potential energy and vice versa. So, what is the principle of conservation of energy? Principle of conservation of energy stated that energy cannot be created or destroyed, but it can be transformed from one form to another, and the total energy in a system is always constant. The total energy before is equal to the total energy after. For a mechanical system where the total energy consists of potential energy and kinetic energy, EP plus EK equal to constant. So hence, the total energy is equal to potential energy plus kinetic energy. Figure below shows how potential energy can be transformed into kinetic energy and vice versa, and the total energy along the track is remaining constant. At the top of a free friction slope, all the energy of a steel ball is potential energy. The potential energy slowly changes to kinetic energy as the steel ball accelerates down the slope. It loses potential energy in accord with its loss of height and subsequently gains kinetic energy. At the bottom of the slope, all of the potential energy has changed to kinetic energy. However, the system has the same total energy whether the steel ball is at the top or bottom. The total energy is approximately 50,000 joules at each point along the track. The combination of potential energy and kinetic energy may be varying at any points, but the total energy always constant. For example, at point A, the kinetic energy is equal to 0, but the potential energy is equal to 50,000 joules. EP is 0 at point D, while EK is maximum. By neglecting the influence of air resistance, it can be said that the total energy of the steel ball, which is 50,000 joules, is conserved during the whole journey. In other words, the total amount of energy possessed by the steel ball is same throughout the whole journey. Energy is neither gained nor lost, only transformed from kinetic energy to potential energy and vice versa. Okay, based on the figure below, we found that for a swinging pendulum, the potential energy and kinetic energy are constantly changing. Potential energy is maximum at point M and S, while kinetic energy are minimum. Also, potential energy is 0 at point Q, while kinetic energy is maximum. The pendulum will stop after some time because the swinging mechanical energy changes to heat energy as a result of resistance of air. Figure below shows an object that falling vertically downward from static. Its loss in potential energy is equal to the amount of kinetic energy gained, assuming that no energy is lost during the process. So from point A, the total energy is equal to the combination of potential energy and kinetic energy. At point C, the total energy is the combination of potential energy at point C with kinetic energy at point C. So please remember that any object that falling vertically downward from static, it's actually lost in potential energy, but at the same time gain kinetic energy. If object is rebound to any height after hitting the ground and left it, its maximum kinetic energy while moving upwards will be equal to its potential energy at its maximum height. For example, at point A, the potential energy is maximum, while at point C, the kinetic energy is maximum. For an object that slides down a friction-free slope, its potential energy is equal to its kinetic energy at the bottom. For example, from point A, the total energy is equal to the combination of potential energy with kinetic energy. At this point, the potential energy is maximum. At point C, the kinetic energy is maximum. Example, a steel ball of a mass of 2 kg is released from a height of 8 meters from the ground. On hitting the ground, the ball rebounds to a height of 3.2 meters. Assuming there is no other energy leaves or enter the system during the process, find number 1, the kinetic energy of the ball as it reaches the ground. Number 2, the velocity of the ball on reaching the ground. And number 3, the kinetic energy of the ball as it leaves the ground on rebound. And number 4, the velocity of the ball on rebound. First, we need to check all the information must using SI unit. For example, mass must be in kilogram and distance or height must be in meter. Question number 1, find the kinetic energy. So we use the principle of conservation of energy, where EK is equal to EP. So in this question, the kinetic energy is equal to 156.96 joule. Question number 2, find the velocity of the ball on reaching the ground. So for this question, we used the kinetic formula EK equal to half mv square. So the answer is equal to 12.52 meter per second. For question number 3, the kinetic energy of the ball as it leaves the ground on rebound. So we use the principle of conservation of energy that says EK equal to EP. So the kinetic energy is equal to the potential energy. So therefore the answer is 62.784 joule. And question number 4, the velocity of the ball on rebound. For these questions, we use the formula for kinetic energy, EK equal to half mv square. So the answer is 7.9 meter per second.